Welcome to Johnson Controls and this state-of-the-art facility. My colleagues and I call this our workplace, and thanks to the heating, ventilation, and air conditioning HVAC system, the conditions are perfect for hosting you in a comfortable working environment. Controlling the temperature and humidity in this environment relies on a sophisticated building automation system and associated machines to move heat from one place to another. The journey this heat takes is not as simple as you might think. Heat energy cannot be directly seen, but its effects certainly can be felt. But what if you could actually see it? Let's take a look at one of our offices. Heat energy has a flow, and given the chance, it will always travel from a higher energy level to a lower energy level. There are many sources of heat energy in most spaces, including this office. Can you see the nice hot cup of coffee? There's our star of the show, Mr. BTU, moving from the high energy level of the hot coffee to the lower energy level of the surrounding air. Before we go any further, let's get to know the little guy. Heat energy in HVAC is quantified in British thermal units, or BTUs. 1 BTU is the heat energy required to raise the temperature of 1 pound of water 1 degree Fahrenheit at sea level. With our simulated ability to see heat, we can identify some sources of heat energy. Heat from outside on a hot summer day will infiltrate into our space. The sun's energy beaming through windows adds BTUs. Any electrical consumption generates BTUs at a rate of 3.4 BTUs per hour per watt. Notice the heat coming off the lighting fixtures and the computers in the room. In a sedentary configuration, most people will generate 450 to 500 BTUs per hour. If they are very active, they could be generating as much as 700 BTUs per hour. If a coworker is generating 0 BTUs per hour, this is a bad sign and will eventually become quite upsetting to anyone working near them. Putting them on a performance improvement plan won't help. Mr. BTU will be the leader of our journey, and he represents the heat energy that we need to remove so we aren't overcome by heat exhaustion. So buckle up and let's ride along as Mr. BTU and all his BTU friends are being moved from our office space. Mr. BTU has transferred into the room air, and an air handling unit is moving him and his entourage towards the return air plenum through a grill. This is not a grill you cook meat on, despite the BTU analogies that could be made, but an opening into the space above the suspended ceiling that leads back to the air handler. Entering the air handler, some small percentage of Mr. BTU's buddies wave goodbye through the exhaust dampers. But Mr. BTU and most of his friends re-enter the main airstream, mixing with fresh air from outside. This is what keeps that oxygen deprivation scenario mentioned before from occurring. After whizzing around in the fan and zipping through a bank of filters, Mr. BTU eventually finds himself traveling across a cold, chilled water coil. Remembering that heat always travels from a higher energy level to a lower energy level, he now enters the chilled water through the walls of the cooling coil. With all of his friends, the effect is to raise the temperature of the chilled water, and heat is removed from the airstream, cooling it down. This air returns to the office at this lower temperature, ready to move more BTUs. Mr. BTU and company, however, are now rafting along in the chilled water, traveling inside piping to a large piece of equipment called a chiller. This specialized machine is designed to remove BTUs from the chilled water, which then cycles back to the air handler to pick up more of Mr. BTU's pals. As the chilled water returns to the chiller, it passes through narrow tubes that are submerged in a liquid chemical refrigerant. By design, any heat added here will cause this refrigerant to boil, changing state from a liquid into a gas. Mr. BTU can't hang around here long though, as a chiller is not designed to store heat energy. So, Mr. BTU makes a trip similar to the one where he entered the chiller, in reverse. After getting mashed about by the compressor, he enters the condenser, and as he travels from the refrigerant gas into the narrow tubes of condenser water, the refrigerant changes state back to a liquid. The BTUs are about to leave the chiller via the condenser water piping. We have made a long journey with Mr. BTU. There is one last stop on the way out of the HVAC system. He is rafting again inside the condenser water piping on the way to freedom. Condenser water is piped into the top of a device called a cooling tower. Cooling towers are designed to reject heat to the atmosphere through evaporative cooling. As Mr. BTU and cohorts are sprayed into the open air inside a cooling tower, airflow around the water droplets in which he is hanging out have less heat energy. By now, you know the drill. Some of the heat energy his gang carries changes the state of the condenser water from a liquid to a gas. Some of it directly transfers to the air. Regardless, Mr. BTU, as the heat from the cup of coffee raised the heat energy of the air in our offices, which raised the heat energy of the chilled water, which raised the heat energy of the chiller refrigerant, which raised the heat energy of the condenser water, has finally been moved to the outside air. He has made the air he's in less dense, and is carried aloft to a new adventure, perhaps in a thunderstorm, then in rainwater, powering a hydroelectric dam, converted as electricity, and into a new cup of coffee.